Okay, so welcome everybody. First, we're going to talk a little bit about streaming architectures, reference architectures, and what to expect. And ultimately, we will be designing a conceptual streaming platform from the ground up. Well, already heard the introductions about us, so we can skip this one. So what is happening in the world today? Data is the big thing. Data is getting bigger and bigger all the time. And data is flowing into the organization from all sides. So from the customer side, there's all kinds of interactions going on different channels, mobile phones, devices, but also from the business partner side, the supply chain. Price updates, inventory updates, location updates. It's getting a continuous stream of events. Also from the internal perspective. So all of your own applications, devices, processes executing. It's getting more and more signals out as early as possible because other parts of the organization want to respond to it. And the same thing with external signals coming from news sites, from AEX market updates. It's a continuous flow of events, and well, that is not something that is particularly new, but what is trendy is that the process needs to speed up quite a lot. So what used to happen in terms of days and weeks is now getting to seconds and milliseconds. And that process is not going to change anytime soon because there are so many different sources coming up that we need to integrate still. This is only just a few, but more and more internet sources, open data, cloud integrations, everything is, tending to integrate into the organizational data infrastructure. And there are three primary motivations why organizations want this integrated and why they want to change. First of all, because simply processes need to speed up quite a lot. Customers expect more, expect it faster, expect it more personal. Business partners equally. Or the second reason is we need to do something about the profitability, to decrease cost or increase revenue, something that makes our bottom line better, or something with compliance. Compliance is a big motivator for many change programs in different organizations, in different sectors. You have to adhere to rules, to regulations, and it's simply not a choice. This is a must. So if you do these changes, then of course we've done them for quite some time already. You have different options on how you can integrate data and integrate systems in your organization. So let's look at a few of them, and this is, by the way, really CEO level. So I often use this comparison to talk to a CEO about streaming without actually talking about streaming. So let's look at how you can integrate different kinds of data, and let's compare that to the human body. So first things first, we started out with batch processing ages ago, and batch processing is kind of like your digestive system. So you typically eat 3 times a day. You eat in batches. If it's 3:30 in the afternoon, you tend to wait until it's 5:30 because you sit down at the dinner table with your whole family. So that it's really time-bound, time-driven. And it follows a fixed and a steady process, but processing also takes a while. So that's the first thing. It's really comparable to data warehouses, data lakes, where you move large data sets around and you process the whole data set. Second way of integrating is, of course, API, everything about API. It used to be service-oriented architecture, web services, request reply. It has had many names. But basically, it's your brain's controlling your muscles. So you continuously send commands like contract or relax, and your arms and your legs will obey the signals that they get. It's much more frequent. It's millions of signals per day. It's individual commands that you send. Usually it's 2 involved parties. It's a server and a client responding to that. and it requires a specific intent. And that intent is often crucial because you send a command to your muscles, either contract or relax, and it's the same thing that you do with APIs. So it's calculate my mortgage or process this meter reading that I got. So that's API. And the third one is actually more comparable to nervous system, and this is where streaming comes in. So streaming is really event-driven. It's like all of the receptors in your skin. It's all eyesight that you get into your brains. Everything you hear, everything you smell, it's all signals coming to the brain. And it's the contextual processing of the brain that determines what you do with that. And that's the same thing with streaming. You can get signals in, but some signals are relevant and some signals are not so relevant. If I press my finger here, I know exactly that I'm doing this, so I won't be surprised that much. But if I'm like this and I feel the same thing, I will definitely start a API call to raise my hand and to see what's going on. And so that's always, so it's a bit of a feedback loop as well. Events are asynchronous and events lead to new processes being controlled by APIs. And you often see all of these coming in a data architecture. So the first one, batch processing and event-driven, those are mainly data-oriented. You talk about data contracts without exactly knowing which system sent the data. The middle one is more command-oriented, and you see that mostly on the edge of the organization or on the edge of a domain, being a formal command that you can receive. So let's look at streaming a little bit in more detail. How does that work? And I think this is something that, well, many people have experience with already. If you have a streaming platform, then signals are coming in from all kinds of different systems, different partners, sensory systems, also observations, maybe process steps that got completed in a certain BPM. And there are basically two kinds of high-level use cases that you can have. We see a lot about process execution, so one signal leading to a process that gets started. We started out in Rabobank initially with financial alerting, so if a transaction happened on a payment account, then somebody may need to be alerted in their mobile banking app. And it's these kinds of process executions that have a lot of transformations associated with it. Mostly deterministic, so it's like if this then that for the enterprise. The second high-level class of use cases that you have is streaming analytics, and this is much more fuzzy often. It's calculating things, it's heuristics being applied. AI, of course, is the big thing now. So it's getting a lot of signals, combining them, and leading up to some sort of a conclusion. And often we do this, of course, to get value out. So real-time dashboards, alerting, anomaly detection, or any kinds of analytics and insights that you want to get out of your streaming data. And it's really comparable to batch processing in the sense that this is just continuous batches of one. That's basically what a streaming platform allows you to set up. But it's not so different from what we've already done for quite some years, because the ETL pattern is something you can just simply apply to this whole mechanism as well. And many organizations are doing this already. An example is Enexis, who's been a customer for quite some time already. They do smart metadata processing, collection and processing on our cloud solution. We're now setting up a system for Norsk Helsenet, which is a Norwegian agency that is responsible for connecting 17,000 organizations in the Norwegian health sector. So they're going to exchange all information on a Kafka platform. And last but not least, we're in the works of creating a new notification system for PostNL. So anytime soon, when you'll be ordering something from bol.com, know that the alert that you get is something that was processed through the Axual platform. So that's fun use cases. It's really close to business. It's something that you can talk to your friends and your family about on a birthday party, which is something that, well, I worked in many different situations, but was not always possible, I would say, not always explainable. And this is really, practical, and it's close to things that people understand. So let's look at what a platform like this looks like. We usually build it up. This is like a reference architecture. We usually build it up in 3 layers, where you have infrastructure at the bottom. On top of that, you have the Kafka layer, the streaming data layer. This is where data gets pushed around, but really in a technical sense. And on top of that, governance, because you need to control that data being pushed around. The middle layer is the layer where you do technical maintenance. So there's a technical maintainer watching out for performance and availability of the whole Kafka system. And this person is basically only doing that. It's somebody with Kubernetes knowledge, with Linux knowledge, know how to operate a command line or to restart a pod, et cetera, et cetera. Typically not somebody that is involved in data definitions in any way, because that is completely left up to teams that want to use the platform as a service. So they will be defining their topics, they will be assigning the schema to that. They will also be the ones that assign access rights to applications. Of course, they build applications that still do the production and consumption of data. But besides that, they want supporting tools as well. They want to call the platform from a CI/CD pipeline, or they want to have everything as code, which is also a topic that will come back in a minute. Everything as code, the topic definitions and access grants also as code. So we're going to peel down this architecture a little bit, because at different levels in the architecture, you want different things. So let's first look at the interface between Kafka and the infrastructure below. And that is something that Ruud will explain to you.
I always start at the bottom. Since I work with Red Hat, I always start presentations at the bottom. I used to work here in application development. And a long time ago, started creating mission-critical applications. I already learned that an infrastructure without workload is nothing. So it's very important to have and to connect with partners like Axual, right? To make to create the workloads for the infrastructure. Otherwise, what's the purpose of having an operating system? And the strength of the whole system is determined by all its components, right? So if you're creating a mission-critical application like a messaging system, right? You should also have like an infrastructure that is at least on par with your non-functional requirements. Okay, let me explain a little bit about OpenShift. For instance, who knows Red Hat? Who's a little bit familiar with Red Hat? Capes. Who knows a little bit about OpenShift? Yeah, who's already using OpenShift in this company? Not everybody. Now, okay, Red Hat is within us for what is it, over 13 years, starting in the 90s with open source Linux, right? Nope. And nowadays Linux is maybe not the most important, but it's a widely used operating system, not only on premise but also in the cloud, right? And OpenShift Linux is Red Hat Linux is a single server operating system, right? It's meant for one piece of hardware running a limited set of applications. So nowadays a lot of applications become larger, right? And customers have the idea that they have to develop systems that are integrated, that are microservices, that run on more than one computer, more than one piece of server, right? So they need like distributed operating systems. And so we have like, who knows about Kubernetes? Yeah, famous, right? So what Red Hat did is they took Kubernetes from the community. It is a gift from, originally developed by Google. We created OpenShift. And it's now the platform of choice for a lot of partners and customers worldwide, not only in the Netherlands, worldwide. So a little bit about the design principles which are relevant for this context, right? For running a mission-critical messaging system in your data center or outside your data center in the cloud. So I want to start with run anywhere. So that was very important for OpenShift, right? That it is able to run anywhere, because our customers have workloads everywhere and anywhere, right? Especially for the networking, what is it? The grid operators. They have workloads that only are allowed to run in a disconnected data center. And not only the grid operators, also we have a lot of customers at the government. So what they need is a platform that also operates within limitations, of course, in a disconnected data center. And OpenShift is one of, maybe even the only one that will operate perfectly in a disconnected data center. But also, a lot of workloads are nowadays going to the cloud, right? Within conditions even, right? And it's allowed to run, for instance, in a data center, public data center in the Netherlands, or maybe even somewhere in Europe, and maybe even in the future it doesn't matter where it runs, right? So it's important that the platform also is supported, and not only works, but is also supported to run in a public data center of choice. To the left side, we think it's very important that the platform you're using, the Kubernetes platform you're using, is really supported and certified to run on, for instance, also hypervisors. So we have good connections with, for instance, VMware. Right? Everybody and his mom is using VMware nowadays, right? But also Nutanix, right? Is one of the providers of hypervisors. And of course on bare metal. We have like good solid connections with, for instance, Dell, of course IBM, our mother, but still also our partner, and with Intel and with NVIDIA for the GPUs, etc. Okay, set aside, you can have and use your OpenShift platform self-managed, or if you don't have the skills or the time or any good reason not to do it yourself, we also offer OpenShift managed, either by a partner, a local partner in the Netherlands or in Europe, or by, for instance, if you run it in the public cloud, you can have your OpenShift managed by the cloud provider. So the other one is run anywhere, even on the edge. We have our edge place, and I know that for the grid operators, the edge is also important. A difficult or complex question is, what is considered edge? For Red Hat, everything outside the data center is considered edge. Could be that for a grid operator, yet something else. But it doesn't matter. There are a lot of gray areas between your own data center, right, and the final far edge. But wherever you run your workload, you wanted to have it run on a platform that is secure, solid, maintained, certified, and all, right? So that's what Red Hat is doing as well. We provide you the platforms, not only for your core data center, not only disconnected, but also in the file. The only thing we don't do, we don't provide the edge hardware, right? So we're cooperating with partners that provide these edge devices, and we see that it is certified and run perfectly. Okay, another one, always on. Who wants his software to be always on? My wife does. Now, you can laugh about it, but it is actually very difficult to have your systems 24/7, right, running without downtime. Actually, I don't think there's any system that can run forever, except maybe for the Olympic flame, what is it? That will run forever. Now, joking. So the only thing you can do is do your best and make your system redundant and choose an architecture what at least helps making your system meet the 24/7 uptime, right? And with OpenShift, we know because it's running for a lot of mission critical workloads, it is designed and built and created and maintained to be always on, right? This is just an example of an architecture, but everything is very redundant. Now you say, okay, but then I need a lot of compute. I see you nodding. Yes, you do, but that's the choice, right? And what we also offer is like smaller versions of OpenShift, but will run, for instance, on 3 servers if necessary. But these are meant for dedicated workloads, right? But it is possible. We even have like single node OpenShift. If that installation fails, okay, it's what it is, right? Then you lose your workload. But for sometimes that could be more than perfect. Okay, security, not a lot to tell about that. I will skip this one. It's very important. Just one thing to let you know, for Red Hat, security is one of the main business drivers, right? That sets us aside from the other open source platforms. We care about security. And that meaning that we spend a lot of time and a lot of effort to create a secure platform, right? And security is not only providing you the latest patches if a hacker has done something wrong, right? That's what we do, of course, but also helping you to harden your operating systems, including OpenShift, and also to have like a lot of tools in place for defending your platform and your system. And we are not the only one. There are a lot of other vendors that provide security tools, and we are more than happy to cooperate with them. We certify also software from third parties that can secure your whole system. I will skip this one. It's very technical. But if it's your interest, just let me know. I can talk the whole afternoon and a piece of the evening about security. Okay, enterprise open source, very important. Jeroen also mentioned part of Axual is based on open source. Like, for instance, the big engine, the Kafka engine, it is open source. Right? It's developed in open source. It is maintained in open source. And that is very, in the communities, and that is very good. For Red Hat, every piece of software Red Hat supports is developed in communities. And we contribute a lot to it, more than a lot even, right? And also OpenShift is, in fact, based on not 1 million projects. I didn't count them, but at least a lot. And many of these projects we cooperate, we contribute, sometimes we dominate, and we integrate it to a working version of Kubernetes. And it's a lot more kind of basic. You need to add a lot more components to make it an enterprise solution. This is what we do. We also stabilize, support. We have training and certifications. We have connections with our partners, also on the hardware side and on the workload side. This is what we do. Last one, and then I give the clicker back to Jeroen. Very important. Wondering who is already on the Everything as Code train? Not many. Well, it is a best practice in IT nowadays that actually at least your application is as code, right? You write it, or you let it write to somebody else. You compile it, you build it, and you can install it. But nowadays we also say, okay, the whole infrastructure, including the middleware, actually should be treated like code. And OpenShift, by design, is as code, meaning that everything you see, this is just an example of an OpenShift cluster with a lot of running components, is defined in code, in a configuration file, right? Meaning that if you install it, you only have to create like a file with actually defining what your cluster should look like. So you're not installing it by on a command line and doing all things and integrating it. No, you define what you want and let OpenShift deploy it themselves and actually also maintain the differences, the state. We're also asking our partners to at least do the same with their workloads running on OpenShift. Make it as code. Okay, this is just an example. I'll skip it. Give it back to Jeroen. He will talk from the bottom up to the top.
We have one small shift coming up, but that's for a later slide. All right, so if we start filling this reference architecture with products, we now firmly established that Red Hat OpenShift is a very good choice for your infrastructure as code, for your infrastructure as a service need for the streaming platform on top. So let's look at the other interfaces and what we aim to achieve there. First one is, of course, applications they need to produce and consume. And the data flows are going on 24/7, so this is something that needs to be provided as a service at all times. And actually, it's also for the governance layer above, that also needs to be able to access the configuration and then change configuration of Kafka at any time. So let's look at how you can realize Kafka as a service. I think by far the most relevant choice for open source Kafka at the moment is to use the Strimzi operator. Strimzi has surfaced as one of the leading operators in the market, and it has a lot of very nice properties that you also saw in Ruud's presentation about infrastructure as code. So it's very robust, stable, it's designed to be always on. It can do special kinds of restarts to keep the cluster up and running all the time, but with the ability to do upgrades. It's enterprise open source, fully supported by Axual as well. So that's very nice. A lot of organizations are already using Strimzi at the moment. And if you look at the website, you'll find some more organizations that actively use Strimzi, two which have a very nice logo. And I don't know if you've seen the news recently, but Strimzi is now becoming so mature that it's joined as a CNCF incubator project, which indicates that this is really becoming like a standard for open source internet software. Actually, I don't know if you've also seen this one, but the very first StrimziCon is coming up. It's an online event, which is hosted on the 22nd of May this year. So if you haven't done so, please subscribe, and you'll find very nice content that day. And there's also some very good and eligible people in the program committee. No, this is something we really thank a lot to Strimzi. We're actively contributing to it, and our colleague Richard Bos is next to the Red Hat colleagues, also part of the program committee. So we're really cozying up more and more to the Strimzi community. All right, so that gives us our streaming layer, which has a number of components I didn't talk about in detail. But you have Kafka and well, Zookeeper for the moment, for as long as it lasts. Strimzi is actively working on getting K-Raft production ready. We didn't talk about the schema registry a lot, but this is where data contracts are negotiated and exchanged. There's open source API Curio in our platform for that as well. REST proxy, which allows applications to produce and consume using REST. And we also have a component called distributor, which allows you to synchronize clusters. And that is one of the components that Eneco is also using to integrate their cloud cluster with on-prem. So that gives you a number of components that completely fill up the streaming layer in the middle. And that's what gives you your Kafka as a service. So let's look at what other interfaces that we have. On top of that, the governance layer, of course, controls the whole Kafka layer, can access the Kafka layer at any time, configure it, and it's the only component that configures Kafka, which is important because we don't want random applications to just generate topics and start producing data or get access to data. So it's the only layer that configures Kafka below. But of course, this layer is not operating by itself. It's controlled by teams, which often start with a UI. And well, I see some hands raised for people that are already on the infrastructure as code. We'll get to that in a minute. But normally we see a lot of organizations that start out with streaming to use a UI. They want a UI that helps them set up the whole infrastructure, set up the whole streaming topology in a nice and intuitive way. And that is what we always aimed with self-service. It's the UI that we introduced in 2018, which sits on top of the Kafka platform. And the UI helps teams who don't know much about Kafka, who do not necessarily want to know about Kafka. if you're a mortgage team, mortgage application team, or if you're a data collection team, you may have a requirement to put your data onto Kafka, but if the requirement says you should put it on RabbitMQ or on any other MQ, that would also have been fine, right? But it's mostly the organization, the enterprise architecture context that determines that you need to put this on Kafka. For those kinds of teams that don't want to get too much involved with Kafka details, this UI is ideal because it allows you to simply click through a few screens and you're helped to setting up topics. You can be helped to configure your connectors, and you're also helped to configure your access credentials. Now we've had a lot of experience with securing the Kafka platform with a mutual TLS, with certificates. And it's rule number 1, if it's not working, check the SSL certificate. Rule number 2, revisit rule number 1, because it's probably still the SSL certificate. So this is a big hassle, and it's made easy by allowing you to just simply upload it. We'll parse the credentials, and we'll make sure that the credentials are set in the proper way. We used to do this manually until people, they are very creative and they start to put email addresses in the certificate, or even host names, or even random characters like ampersand signs and all that. That gives you wonderful. I remember one day, I think it took us 5 or 6 hours to find out that somebody put a space at the end of the certificate name. Finding that out was just a hell on a Friday afternoon. But finally we found it and we made it work. But I mean, these kinds of situations you definitely want to avoid, because if this gets to be a standard process and people want to connect but they can't, your whole platform will be rejected, because that's the annoyances that they go through. Another part of the UI is, of course, the visualization of topologies. So if you know about all applications, if you know about what they do on what particular topics, you're able to graph the entire flow. And this is a flow where you see what applications produce to which topics, and then what applications consume again out until the very end, where in this case some patient data for the Norwegian health customer was produced. Having this overview, not only as a team, but also as a solution architect, enterprise architect, gives you the ability to know what is going on your platform at any time. And that gives you, of course, the control plane UI. There's also an API part, because ultimately, when you mature your streaming usage, you don't want everything to be done manually through a UI. You want to be capturing things as code. So like Ruud said, in configuration files that make it deterministic what your setup is like. And that also helps you to expedite recovery should disaster strike, or should you need to reinstall your whole platform. So there's a number of mechanisms supported in the platform for that. If you go to the documentation side, then on the CI/CD support, there's the management API documentation, which describes the full API in an open API format. So everything that you can do through the UI is also available through the API. In fact, the UI is just another API client, and it's not any special thing in the whole platform. So that allows you to directly call API, but it's not something that every team wants to do. Often teams also want the infrastructure as code way. So we have our own open source Terraform provider, which allows you to specify your resources in your own Git repository. And that's important for teams that want to collaborate. We see a lot of organizations, they have like a central repository for holding all topic configurations and all access rights and all that. With this Terraform to GitOps level 4, which means that everybody keeps a part of the configuration in their own Git repository. So your pipeline will parse the definitions that you have in your own Git and then deploy them via the API to the actual platform. And there's a lot of code examples that you can use to find out how that works. So in total, the whole governance layer is made up of a number of components. The API in the middle is what you saw in the documentation. Self-service is just another API client. Terraform is just another API client, or you can do it yourself. And in the back, we have an organization manager, which is used to bootstrap the entire platform, setting up the first tenant, the first users, determining who is the admin and all that, and who can log on. A metric exposer, which allows teams to create their own dashboards. So you can set up your own Grafana if you want, and just get your metrics out of the platform and monitor that. And the most important component, the platform manager, which holds all the metadata in a database. So all your topic definitions, all your schema. And there's a library which we nowadays call Chameleon, because everything in the Kafka world has to start with a K. And Chameleon is able to adapt to any kind of Kafka. So besides plain Kafka, AMQ streams, and our own Strimzi, we're even able to adapt to Avon and Confluent. So these possibilities are all there to use. And that gives us the top layer filled in with actual governance. Only a few things to discuss still. There's that maintainer on the right, which also has a need for specific things, mostly for monitoring, for logs and alerting. The joint stack of Red Hat and Axual together, they have tooling for this. So
a little bit about the way of interconnecting with OpenShift is like we provide you at least all the capabilities to do it your way. I'm from in the 90s, we didn't have any web UI or whatever you write. So I'm a command line cowboy. And still, Linux and OpenShift is very well equipped with a command line interface. And in the end of the day, maybe it's also what you want to automate and to have your whole system like as code, right? But to just check what you created, what you came up with, is actually also what you want. We have a wonderful web UI, so you can also check how it looks like. This is just an example of a developer view, right? We make it very graphical. All the the components you see, these are OpenShift Kubernetes artifacts, right? Either they're roots or small applications, microservices, containers. It's all visual, right? But the most important thing is you have choice, right? And you choose whatever you like and whatever suits your way of working. Yeah. Also a little bit about operators. Who is aware of the concept of operators, Kubernetes operators? A little bit, right? Not many. It's a very important construct. It's actually the operator is just a piece of software mimicking your system's admin. So everything your system's admin knows about managing systems, also the workloads, you can incorporate in a piece of software called the operator. It's an extension of the Kubernetes framework. It's fully supported by Red Hat and OpenShift. You can create also your own operator. So the platform itself has a lot of operators to keep it running. You can also create your own. Strimzi, for instance, is an operator for Kafka. You can create your own if you're creating an application on top of OpenShift to cooperate and to work with Axual. It would be very nice if you're also creating an operator for your own application. And you can do it very simple by, if you're a Go programmer, I don't think many of you are Go programmers, no. But some of you know maybe Ansible, it's automation tool. You can create an Ansible playbook to install and to manage your application and to have it converted to an operator. So at least your application is also as code, right? I'll give it back to you.
All right, that was the last one. Yes, and of course, on the actual side, we also have quite a lot of monitoring and logging possibilities. Many organizations already have something for that in place because you don't want any new platform or any new piece of software to just bring their own monitoring tools. But if you don't, or if you prefer to go for the standardized option, we supply Prometheus Grafana and Prometheus Alert Manager for that. So when things get out of bounds, when your application stops producing, when topics don't get any information, you can set alerts and be alerted in any way. Scripts you can write to do it via SMS, or you just send an email. Or so that's all there. Elk and Splunk integration to get all logging out, audit logging, functional logging, technical logging, anything that you need. So that's all also covered in the whole installation. So well, this gives us our reference architecture and the things that we need to set it up and the things that we need to get it running and to maintain running it. But often the most important part is not in this set of interfaces, because where the platform allows you to scale is basically when teams start to write applications. And it's exactly this interface which gives you your developer productivity. So what accelerators are in the platform to allow you to quickly set up a new integration or to quickly define a new application. But there's a number of ways you can do that. Of course, Kafka Connect provides a way. So there's a bunch of connectors that's listed on the website, but I think it's what I heard this morning. It's not even complete, so we need to update that. But the idea is that you can get from different sources, you can get data in and get it produced onto Kafka, or from Kafka exported to some external data system. Many integrations are standard out-of-the-box supported. But there's also a need to do these circles that you saw on the earlier picture, the transformations. And for that, we are working for a number of years already on a tool called KSML, which is the Kafka Streams markup language. And that allows you to specify a streaming application as code, but in a very simplistic way. So you can define what topics you want to use, how your pipelines are configured. And this is, for example, an application that just reads sensor data messages from a specific topic and only filters, lets the messages pass which have a color field called blue. Very easy, but that's often what teams need. We talked about analytics, we talked about AI and all that. That is often we find just a small percentage of what teams need. I remember a number of years ago we were talking to Rabobank. They had a stream with transactions, credit card transactions, and anybody could see that, but this one application was not allowed to see the credit card numbers. So we needed a second stream containing the same information, but just with a crossed out credit card number. That is like this big of a business logic lines of code. But you have to set up a Java team. There's a microservice to be created. There is a pipeline to be set up. It needs to compile. It needs to go through different phrases. It is a lot of overhead for 2 lines of business code. And that's exactly the use case that KSML intends to cover. Simple applications that you can just upload the YAML for in self-service. You can press play, and then it starts on a server on your behalf. So that is what we will soon be introducing into the next version of Axual Platform to allow you to run these kinds of simple operations. And that gives us our entire stack. So giving all the requirements that the different actors around the platform have, and a combination of Axual and Red Hat can fulfill that. And that gives us the entire stack in a bit more detail, but I'll skip this one because I think we talked about most of them. Well, as Jelle already indicated in his opening talk, last year we became Red Hat certified, so everything is now also available through the Red Hat ecosystem catalog, which makes it a very easy way to acquire and to use the software in your own environments. So let's look at a few do's and don'ts, starting out with the don'ts, because if you have a reference architecture like this, you still need to work around this. And a couple of don'ts that we experienced over time which we learned from a lot, is are going to be listed on this page. Often we come across organizations that approach us and they ask us, can you help us with our Kafka, because we got stuck. They started out with a technical team, 2 or 3 Kafka enthusiasts. They installed Kafka, started with a use case, didn't care too much about security, didn't work much through the architecture. So at some point, more and more teams want to onboard, want to use it. You can decide to either launch new Kafka clusters, or you can maybe onboard them onto the same Kafka cluster. But what is your long-term vision? That is often undecided. Who are your customers, your internal customers? What kinds of policies would you want to adopt? What kinds of data modeling standards would you want to adopt? It's very important that you know what the purpose of your Kafka platform is and who will be using it. So really, don't start without the end goal in mind. Second one is to mix technical and functional maintenance. We saw a lot of customers where the Kafka team was also doing the functional maintenance, the setting up of topics, the registering of applications, the awarding access rights. It is a hassle. We used to do this ourselves, so that's also why we learned this. It's even the reason why we got started with self-service, because we used to have a functional mailbox where people would send us emails. Can you please set up this topic for me? Can you award this application access to this particular topic? And basically, us as maintainers of the platform, it was just boring work, because at some point you lose track of who is emailing you or who gets to decide what. So that's exactly the purpose why we started building the self-service UI. You want to split that. You want teams to just help themselves and not be responsible for any configuration changes or any configuration omissions. So mixing that is another good practice. And last one, assume that teams will just pick this up is also something that is just a wrong assumption. Event-driven architecture is really a new concept. It's something that you need to adapt to. It's something that you need to live through to know what you're talking about. It's not just wrapping a database in a Kafka form. And we saw customers do that. We recently had a POC with an Irish bank where they just asked us in the POC to mimic a database application on Kafka. And we only found that out while going through the whole process with them. And this is, in the end, we managed to get something done for their POC because it needed to be proven internally, but it was just a painful experience. So really know that event-driven architecture is different. You need to live through that to understand how it changes your design philosophy. So what do you want to do if you adopt a system like this? Well, the first thing, of course, is to have that long-term vision. Who are your end users? Who will be using your platform? What do they expect? What requirements do they have? We talked about reference architecture and all those interfaces, but do these interfaces apply to your organization, to your Kafka platform? And if you do, if they do or if they don't, manage the whole experience. Often you start by acquiring or installing software, and then what? You have a first use case, it works, and then how do you continue with that? So have a process where you can recognize these phases, start out small, and then allow scaling over time. To scale, you really need this enabling team. The Kafka team itself is often just busy with stabilizing and running the Kafka platform, but there are a lot of questions around setting up applications that work with Kafka. And I think it's also going to be a topic in Rob's presentation in a minute. That enablement team has to have Kafka skills, but it also has to have development skills, because you're going to get questions on what frameworks do I want to use? How do I do testing on Kafka? What kinds of clients or languages I can use? And that also requires consultancy skills. So being able to listen to people, to hear about what their intentions are, to see through the design failures that they made and maybe guide them on their way to a better implementation. That's really something that requires skill, and it's definitely needed to get your first projects running, and also to later on define the standards in your organization. But having learned a few things, then this is the way we want topics to be named, or this is the way we want events to be designed. And of course, the last one, you don't have to do everything yourself. There's a partner ecosystem which you can fall back on. These are just a few partners that we work with in the Netherlands already. They can help you in defining your standards, setting up the system, maintaining them, doing architecture, having people for that enablement team. So it's deciding on what you want to do yourself and what you want others to help you with. But not having the skills is not necessarily a reason to not go ahead with implementing the platform. All right, that brings us to the end of this first presentation.